This video is going to be on calcium physiology and how we measure calcium in the ClinPath lab. So first I'll draw an enterocyte, which is this pink thing with a black nucleus. And then I'll also draw a blood vessel. And I'm drawing these structures to demonstrate that calcium is normally absorbed in the diet. That's how we acquire calcium within the body. So calcium, those little blue circles, are being absorbed and they enter the blood. And this absorption is enhanced by two hormones, the first of which is vitamin D, and the second of which is parathyroid hormone, or PTH. So both of those hormones enhance calcium absorption from the diet. Now within the blood, there are various fractions of calcium, and I'm going to draw a pie chart to represent those fractions. The first of which is the free calcium, or the ionized calcium. Both of those are synonymous. And this portion makes up about 50% of the total calcium in blood. And this is an important form of calcium because that's the form that's metabolically active. However, it's a little bit tricky to measure in that you do need a blood gas analyzer to measure calcium, and it's not the form that we measure on our routine serum chemistry panel. The other fraction of calcium is the protein-bound fraction, and about 40% makes up this component. And the majority of the protein-bound fraction is bound to albumin, and that will come up later when we talk about causes of hypocalcemia. And then the smallest fraction is the 10% fraction, which is also bound, but it's not bound to proteins. It's bound to other things, other negatively charged things. So the protein that we measure on our serum or plasma chemistry panel is the total calcium. It consists of free calcium, protein-bound calcium, and non-protein-bound calcium, whereas the free or ionized calcium is measured on the blood gas. Okay, so now going back to calcium physiology, again, calcium within the blood is deposited in bone, and it's also bone acts as a reservoir. So calcium moves back and forth between bone, depending again on hormonal influences. So calcium resorption from bone is enhanced by vitamin D and PTH and inhibited by calcitonin. And you'll see these hormones pop up again and again when I talk about calcium and phosphorus physiology and disease. Now the body can get rid of calcium, and it can do so by the kidney. So I'm going to draw a kidney here with the afferent and efferent blood vessels, and then also the ureter. And of course the blood vessels are attached to other blood vessels in the body, so I'm going to draw them attached to the main blood vessel. So calcium is freely filtered by the glomerulus, and what happens to that calcium in the kidney depends on those hormonal influences. So the calcium can either be resorbed and enters blood again, or it can be excreted in the urine. So things that enhance calcium resorption include, again, vitamin D and PTH. Both of those enhance calcium resorption by the tubule, so calcium is maintained or retained within the blood and not excreted. However, this resorption is inhibited by calcitonin. So since it's inhibited, that means that less calcium is resorbed and more calcium ends up in the urine. So when we're talking about these hormonal regulations, it's important to know the overall effect of these hormones. So I'm going to erase the top part of this blood vessel so I have more room to write. So the net effect of vitamin D is to increase calcium in the blood. The net effect of PTH is to also increase calcium within the blood. And then calcitonin, that's the different one that tones down calcium. So its job is to decrease calcium in the blood. So just think of tone down calcitonin, tones down calcium. So that's it, a general overview of calcium physiology and then also the hormonal regulations of calcium concentrations within blood.